Hello, friends. Welcome to this journey across the solar system. Today, we're diving into the history, mysteries, and secrets of a planet that, at first glance, looks so much like Earth, but in reality is its complete opposite. I'm talking about Venus, Earth's closest neighbor and the second planet from the Sun. Many people call Venus the sister planet of Earth because the two are almost the same size and share a similar composition. But once you take a closer look, the illusion of similarity vanishes. If Earth is a cradle of life, Venus is a fiery inferno, a place where temperatures are hot enough to melt lead, where the atmospheric pressure would crush any spacecraft in minutes, and where the clouds are made of sulfuric acid. And yet, it wasn't always like this. Billions of years ago, Venus may have been a paradise, a world with oceans, a mild climate, and perhaps even the right conditions for life. Then, something catastrophic happened, transforming this twin of Earth into a blazing hellscape. And today, scientists are still asking, what exactly went wrong? Venus is the second planet from the Sun, and sunlight reaches it in just 6 minutes. By size, it's almost Earth's twin, about 12,100 kilometers in diameter, only a few hundred kilometers smaller than Earth. A year on Venus, its orbital period lasts 224 Earth days. But here's the strange part. A single Venusian day is longer than its year. Venus takes 243 Earth days to spin once on its axis. And it spins backwards compared to most other planets, a phenomenon called retrograde rotation. If you could stand on its surface, you would see the sun rise in the west and set in the east. Venus is also one of the brightest objects in our night sky. Known as both the morning star and the evening star, it can often be seen with the naked eye just before sunrise or right after sunset, shining so brightly that it can even cast shadows. But why do scientists care so much about Venus? Why do we keep sending missions there, despite how dangerous and costly it is? First, because Venus holds answers to one of the biggest questions. How do planets like Earth evolve? Billions of years ago, Venus may have followed a path similar to our planets. If it once had oceans and a stable climate, what caused it to change so drastically? And could the same thing ever happen to Earth? Second, Venus is a natural laboratory for extreme science. Studying its atmosphere with its runaway greenhouse effect, sulfuric acid clouds, and hurricane-speed winds helps us better understand how climates change and how atmospheres behave. And that knowledge may be critical for understanding Earth's own future. Finally, Venus is simply a challenge. Every mission we've sent there has faced enormous difficulties. Spacecraft are crushed, melted, or disabled within minutes of landing. But that's exactly what makes it so fascinating. Venus dares us to try, and humanity can't resist a challenge. If you ask scientists what makes Venus so unique, the answer will almost always begin with its atmosphere. The Venusian atmosphere is incredibly dense, toxic, and dangerous. Standing on the surface would feel like being crushed a kilometer underwater, but instead of water, you'd be surrounded by a choking, poisonous mix of gases. The atmosphere is made up of 96% carbon dioxide, with traces of nitrogen and a cocktail of other chemicals, including sulfur dioxide. This thick carbon dioxide blanket is responsible for the strongest greenhouse effect in the solar system. Here on Earth, the greenhouse effect is what makes our planet habitable. But on Venus, the same process spiraled completely out of control. Sunlight penetrates the atmosphere, heating the planet's surface, but the heat cannot escape back into space. Instead, it's trapped, bouncing around within the thick, carbon dioxide-rich atmosphere. The result? Surface temperatures reach up to 465 degrees Celsius, 869 degrees Fahrenheit. hot enough to melt lead, zinc, or tin. Venus is even hotter than Mercury, despite being further away from the Sunday. And if the heat wasn't enough, the pressure is another nightmare. The surface pressure of Venus is about 92 times greater than Earth's. Imagine standing on Earth with almost a kilometer of ocean above your head. That's the kind of crushing force you would feel. Any unprotected spacecraft or person would be destroyed in moments. High above the surface, Venus is shrouded in thick clouds of sulfuric acid. These clouds not only trap heat, but also reflect sunlight, which is why Venus appears so bright in our skies. But inside those clouds, conditions are terrifying. Acidic droplets, high winds, and constant storms. In fact, the upper atmosphere is home to the phenomenon known as superrotation. Winds whip around the planet at speeds of over 300 kilometers per hour, 186 miles per hour, circling Venus completely in just 4 Earth days. That's much faster than the planet itself rotates. What's most fascinating is that billions of years ago, Venus may have had a stable and even pleasant climate. Some models suggest oceans of liquid water, mild temperatures between 20-50 degrees Celsius, and an atmosphere not so different from Earth's. But then, something catastrophic happened. The greenhouse effect spiraled out of control. The oceans boiled away, and Venus turned into the blazing inferno we see today. This dramatic transformation raises some of the biggest mysteries in planetary science. Was Venus ever habitable? And if so, for how long? To understand that, we need to study its geology and surface features, which may hold clues to what really happened. When we look at Venus through a telescope, we can't see its surface. The thick cloud cover hides everything from view. For centuries, astronomers imagined oceans, jungles, or deserts beneath those clouds. It wasn't until the second half of the 20th century, thanks to radar mapping and landers, that we finally uncovered the true face of Venus. What we discovered was both alien and strangely familiar. A rocky world, covered in mountains, valleys, plains, and volcanoes, but with conditions utterly unlike anything on Earth. One of the most striking features of Venus is its volcanic landscape. In fact, Venus has more volcanoes than any other planet in the solar system, over 1,600 major volcanic structures and countless smaller ones. Some are small shield volcanoes, while others are enormous, stretching hundreds of kilometers across. The largest volcano, Mount Mons, rises about 8 kilometers high, nearly the height of Mount Everest, and covers an area the size of a small country. But the real mystery is whether these volcanoes are still active today. Evidence suggests they might be. In recent years, data from orbiters has shown changes in thermal emissions and even possible fresh lava flows. If confirmed, it means Venus is still geologically alive, with eruptions reshaping its surface. Unlike Earth, Venus doesn't have plate tectonics, the shifting of massive plates that creates earthquakes and mountains here on our planet. Instead, Venus seems to release its internal heat through massive upwellings and collapses in its crust. This has created unique geological features. Coronae, huge circular structures, sometimes over 1,000 kilometers across, formed by plumes of hot material rising from deep within the mantle. Rift valleys, cracks, and fractures that stretch for thousands of kilometers. Lava plains, vast flatlands, created by ancient volcanic eruptions that flooded entire regions with molten rock. Venus also has massive highland regions. The most famous is Ishtar Terra, home to mountain ranges like Maxwell Montes, which rise almost 11 kilometers above the mean surface level, higher than Mount Everest. But unlike Earth's mountains, which are formed by colliding tectonic plates, Venus's ranges likely formed through crustal compression and volcanic activity. Interestingly, Venus has relatively few impact craters compared to bodies like the Moon or Mercury. This suggests that its surface is geologically young, perhaps only 300–500 million years old. Scientists believe Venus underwent a catastrophic resurfacing event, where volcanic activity renewed much of the planet's surface in one gigantic episode. All of this makes Venus a geological puzzle. Why does it lack plate tectonics? What caused its catastrophic resurfacing? And how does its geology connect with its runaway greenhouse atmosphere? Venus forces us to think about Earth in a new way. By studying its geology, we may better understand how planets evolve, why some remain habitable, and why others become deadly worlds of fire. Now that we've uncovered the secrets of Venus's surface and geology, let's take a look at humanity's efforts to actually reach this planet, missions that risked everything to reveal its mysteries. Venus has always fascinated humanity. For centuries, people looked at it as the brightest object in the night sky, imagining oceans, forests, or even civilizations hidden beneath the clouds. But only with the dawn of the space age did we finally get the chance to explore it up close. Exploring Venus, however, has proven to be one of the greatest challenges in planetary science. Its crushing pressure, scorching heat, and corrosive atmosphere destroy spacecraft within minutes. And yet, despite these hostile conditions, humanity has managed to unlock many of its secrets. The Soviet Union was the first to attempt and succeed at reaching Venus. Starting in the 1960 seconds, they launched the Venera program, a series of missions that would become historic. Venera 11961, the very first spacecraft sent toward Venus. Unfortunately, contact was lost before it reached the planet. Venera 31965, the first human-made object to crash land on another planet. It impacted Venus, though it failed to send back data. Venera 71970, a true milestone. It became the first spacecraft to successfully transmit data from the surface of another planet. It survived for 23 minutes in Venus's brutal conditions before its systems failed. Venera 9101975. These missions delivered the first black and white photographs from the surface of Venus. The images revealed a rocky, barren landscape under a yellow sky. Venera 13 and 141982. These were the most successful landers. They sent back the first color photographs, recorded sounds from the surface, and even analyzed the chemical composition of Venusian rocks. These missions were groundbreaking. They showed us that Venus was not a lush jungle as some had hoped, but a deadly world of fire and stone. While the Soviets were landing probes, NASA focused on flybys and orbiters. Mariner 21962, the first successful mission to another planet. It flew by Venus and measured its temperature, proving that the surface was extremely hot. Pioneer, Venus Orbiter, and Multi-Probe 1978. This mission mapped the atmosphere, studied the magnetic field, and sent probes plunging into the clouds. For the first time, we began to understand the structure of Venus's dense atmosphere layer by layer. The thick clouds of Venus made it impossible to see its surface with ordinary cameras. That's where NASA's Magellan spacecraft came in. Launched in 1989, Magellan used radar to see through the clouds and map the planet's surface in unprecedented detail. The result was a nearly complete global map, revealing mountains, volcanoes, plains, and impact craters. Magellan showed us the strange geology of Venus, including giant volcanic structures called coronae, and evidence of past resurfacing events. After the American and Soviet programs slowed down, other countries stepped in. ESA's Venus Express, 2005-2014. This European mission studied the atmosphere in detail, discovering how dynamic and extreme it truly is. It observed powerful winds, atmospheric vortices, and hints of volcanic activity. Japan's Akatsuki launched 2010. After an initial failure, Akatsuki successfully entered Venus's orbit in 2015. It has since been monitoring the planet's climate, cloud structures, and mysterious atmospheric waves. Today, interest in Venus is stronger than ever. NASA and ESA have both announced ambitious new missions. VERITAS, NASA, 2030 seconds. An orbiter designed to map the surface in high resolution and study tectonic and volcanic activity. DAVINCI, plus NASA, 2030 seconds. A probe that will descend through the atmosphere, analyzing its chemistry and searching for signs of past habitability. Envision, ESA, 2030 seconds. Another orbiter that will study the geology, interior, and atmosphere of Venus in detail. Together, these missions could answer one of the biggest questions in planetary science. Was Venus ever a habitable world? The exploration of Venus is a story of triumph and tragedy, of human persistence against nearly impossible odds. Every mission faced incredible risks, and many failed. But each success brought us closer to understanding a world that is both Earth's twin and its total opposite. And as new spacecraft prepare to visit Venus in the coming decades, we stand at the edge of a new chapter. Perhaps, in the near future, we will finally uncover the secrets of how Venus transformed and what it can teach us about our own planet's fate. Imagine a world that may once have been covered with shallow oceans, with a mild climate, perhaps even with conditions suitable for life. Now imagine that world suddenly transforming into a blazing inferno, with surface temperatures hot enough to melt lead, and an atmosphere so dense it could crush a submarine. That is the mystery of Venus. According to planetary scientists, something dramatic happened about 700 million years ago, a planetary catastrophe that turned Venus into the hellscape we see today. Radar maps from NASA's Magellan mission reveal something surprising. Venus has relatively few impact craters compared to other rocky worlds. On the Moon and Mercury, craters have accumulated for billions of years. But Venus's surface looks much younger, perhaps only 300 to 700 million years old. The leading theory is that Venus underwent a global resurfacing event. Vast amounts of magma erupted across the planet, flooding 80% of the surface with new lava. This wasn't just a few volcanoes, it was a planetary-scale transformation, covering plains, mountains, and craters alike with molten rock. Those eruptions had a side effect. They released massive amounts of carbon dioxide into the atmosphere. On Earth, when CO2 is emitted by volcanoes, much of it gets absorbed back into rocks through weathering processes. But on Venus, things were different. The lava cooled and solidified into a thick, impermeable crust. That crust acted like a seal, preventing the planet's surface from reabsorbing the carbon dioxide. The result was catastrophic. The atmosphere became loaded with greenhouse gases, and the climate spiraled into a runaway greenhouse effect. Temperatures soared to 465 degrees Celsius, 869 degrees Fahrenheit. The atmosphere thickened until it became 90 times denser than Earth's. Any oceans Venus may once have had were lost forever, boiled away by the heat and blasted into space by solar radiation. Earth has experienced massive volcanic episodes too. About 250 million years ago, the eruption of the Siberian Traps released enough gases to cause one of the largest mass extinctions in history. But even that cataclysm pales compared to what happened on Venus. Why did Earth survive, while Venus didn't? It comes down to delicate balances. Plate tectonics, liquid water, and the carbon cycle on Earth helped reabsorb greenhouse gases. Venus, lacking those safety valves, tipped into an irreversible state. One of the biggest questions scientists still debate is, was the catastrophe a single event, one apocalyptic episode of volcanic flooding? Or was it a series of smaller resurfacing events spread out over hundreds of millions of years? The answer matters because it could tell us whether Venus once had billions of years of habitability, oceans, stable climates, perhaps even life, before its final downfall. Studying this catastrophe isn't just about Venus, it's about Earth's future. Venus is the ultimate warning about what happens when greenhouse gases dominate a planet's climate. It's also a natural laboratory for understanding planetary evolution. By learning what triggered Venus's runaway greenhouse, we can better understand how fragile habitability is. By studying its resurfacing, we test our theories of planetary geology. By connecting Venus to exoplanets, we improve our ability to identify which worlds around distant stars might be Earth-like and which are doomed to become Venus-like. Venus is a reminder that even planets that begin with Earth-like conditions can take very different paths. But to truly solve its mysteries, we need more than theories, we need missions. And that is where humanity's exploration of Venus, past and future, becomes essential. If you were to step onto the surface of Venus today, you wouldn't last a second. The temperature is about 465 degrees Celsius, 869 degrees Fahrenheit, hot enough to melt lead. The pressure is like being almost a kilometer under Earth's oceans. And the clouds? They're not fluffy white cotton, but thick, choking layers of sulfuric acid. Venus is, quite literally, the most hostile place you could imagine. And yet, for decades, scientists and visionaries have asked a daring question. Could we ever change it? Could we terraform Venus into a second Earth? Let's begin with what we're up against. Venus has the most extreme greenhouse effect in the solar system. Its thick atmosphere is 96% carbon dioxide, with clouds of sulfuric acid. Sunlight penetrates the clouds, warms the surface, and the heat cannot escape. That runaway cycle has made Venus hotter even than Mercury, despite Mercury being closer to the Sunday. Winds in the upper atmosphere reach speeds of 720 kilometers per hour, 450 miles per hour, circling the planet in just a few days. Lightning storms flash through the dense clouds. It's a world of superheated gas, crushing pressure, and toxic rain that evaporates before it even touches the ground. This climate is not just a curiosity, it's a warning. Venus shows us how a planet can lose its oceans, its habitability, and its stability when greenhouse gases dominate. Despite all this, some scientists and futurists dream of terraforming Venus. The basic idea is to cool the planet, thin the atmosphere, and somehow restore conditions where liquid water could exist again. But how could that be done? Several radical proposals have been suggested. 1. Solar shades place, gigantic mirrors or shades in space to block some of the sunlight reaching Venus. Over centuries, this might cool the surface and allow carbon dioxide to condense. 2. Atmospheric conversion. Introduce chemical or biological agents, hypothetical microbes, or engineered nanotech that could bind with carbon dioxide and reduce its concentration. 3. Hydrogen bombardment. Some have suggested delivering massive amounts of hydrogen, which could react with CO2 to form water. In theory, Venus could regain oceans, but the scale of hydrogen needed would be astronomical. 4. Floating cities. Perhaps the most practical near-term vision isn't changing Venus at all, but adapting ourselves. About 50 kilometers above the surface, in the upper atmosphere, the temperature and pressure are remarkably Earth-like. Here, concepts of giant floating habitats have been proposed colonies suspended in the clouds of Venus. Of course, these ideas face nearly impossible challenges. The total mass of Venus's atmosphere is about 100 times greater than Earth's. Removing or altering it would require technology far beyond anything humanity currently possesses. Terraforming Venus would not be a project of decades or even centuries. It might take thousands of years, if it's possible at all. But the idea is not pointless. Thinking about terraforming forces us to confront the limits of technology, the scale of planetary engineering, and perhaps most importantly, the lessons of climate change here on Earth. So why talk about it? Because it stretches our imagination. It connects science with philosophy. Venus becomes a mirror showing us both the fragility of habitability and the boldness of human vision. If we could one day make Venus livable, it would prove that humanity has mastered not just surviving in space, but reshaping worlds. And yet, even if we never terraform Venus, the dream itself pushes science forward. It inspires new research on climate, planetary atmospheres, materials, and space engineering. Venus is today a hellish world, but in imagining how we might transform it, we also transform ourselves. We push the boundaries of what's possible, and we remind ourselves that planets, even ones as hostile as Venus, can be both warnings and opportunities. And that brings us to the end of our journey through Venus-Earth's mysterious twin, a world of fire and storms, of myths and science, of warnings and dreams. From its ancient volcanic cataclysm to the crushing atmosphere, from the haunting beauty of the morning star to the futuristic visions of floating cities and terraforming, Venus reminds us how fragile planets can be, and how limitless human imagination truly is. But now, I'd like to hear from you. Do you think humanity will ever set foot on Venus? Do you believe terraforming could one day be possible, or is it just science fiction? And which planet should we explore next in a deep dive like this? Mars, Titan, or maybe Europa? Share your thoughts in the comments. I read them all, and they always spark new ideas for future videos. If you enjoyed this journey, don't forget to leave a like. It really helps the channel. And of course, subscribe so you don't miss our upcoming episodes, where we'll explore more planets, moons, and mysteries of the cosmos. Thank you for watching, and until next time, keep looking up, because the universe is always waiting to be explored.